Okay, good evening, students. As I was grading the week 3 submissions, there was one that really stood out from the others when it came to the linear regression. So one of your peers, one of the students, had submitted this, and I absolutely had to share it back because this is probably the most complete linear regression that I've seen a student submit as part of the coursework as long as we've been teaching this coursework. So I wanted to provide this to you. I'm also going to provide the code back to you as well. But what I've done is I've stripped out the student's identification information in it so that I won't have to embarrass that student. They did give me permission to share it back, but again, as I was going through the grading, this one really stood out. So let me walk you through the code so you kind of understand what's going on here. First off, they did some initial exploratory data analysis on this, and that really wasn't part of the assignment, but I thought that the method that they used in order to do this was fantastic. Using a library called Data Explorer, which again, you can download that, you can do that through a package install, you can get Data Explorer. They created the report on the orange data set. Here is the output that comes out of that. This is a pretty fantastic little data profiling report. And so it'll kind of show you some of the basic statistics. It'll show you raw counts, percentages. It'll show you the data structure. It'll give you some data profiling to go along with that. It'll show you the distribution, so it produces a histogram, as well as a frequency plot, as well as a QQ plot. So these can all kind of help you establish or understand whether or not the relationship between the variables is linear. Now in this case, we're just talking about 3 different variables, but again, you kind of get the idea. This is a good process. It goes through a correlation analysis, and then it goes through a principal component analysis. Now, these last one here, this principal component analysis, is not something typically we get into this course. We get into it in the Data 728, the SPSS Advanced Analytics 2 class. We get into PCA a little bit there, but here's one that R actually does for you. So I wanted to share all of this. So we can see here it has 35 rows. It's not a lot of data that's included with this. Three columns, 35 rows. One of those columns is an ID. So then first thing it does is it gives you these percentages here. It shows you missing, it shows you continuous, it shows you discrete. So this gives you an idea of what the shape of the data is. It then turns around and gives you the data structure. Unfortunately, you can't really see it good on my screen. It's not very dark on my screen. Let me see if I can blow it up here a little bit. But this kind of shows you the individual elements that are included with your data frame. So this is really cool, especially when you have large data sets. This piece here can be quite helpful to you. It shows you the data profiling, so it shows you missing data. And in this case here, you can see that there's no missing data. So overall, everything is good. It shows you the distributions. It shows you frequencies. It shows you the QQ plot. And again, what you're looking for is as much on a single line there as possible. So again, it looks pretty good. The age is a little bit scattered. The circumference is better. It then shows you the correlation analysis on a heat map. This is fantastic, especially when you get multivariate analysis. These are quite useful. These are critical, useful things for you. So here, just looking at this visually, if I'm looking at age compared to circumference, I see that it's got a correlation of 0.91, which is really close to 1. So this is telling me that there's a strong correlation between age and circumference. And you can kind of see it also shows the identifiers for the different trees here. That's going to be of less value to us. Principal component analysis, again, this is a more advanced dimensionality reduction technique. We're only talking about 3 columns, so this really doesn't apply. But if you look at a larger data set, get some of the larger data sets that are out there with a lot more data elements in them, principal component analysis, to have this done for you would be really great. And again, this shows you even the feature and the relative importance of those features back to it. So this is a really handy EDA tool that's out there. It's called Data Explorer. If you've used Python and you've used Pandas profiling, for instance, it's very similar to the output that Pandas profiling does in Python. So student did include that, and again, kudos. That's a really good call out. Wasn't part of the assignment, but I wanted to highlight that to you as well. The next, excuse me. Excuse me. The next thing that they do is they attach the orange data set. Now, normally when you just you load up R, R is automatically going to be attached to R, but to have this as the extra step in there, again, that's good practice. So at this point here, you no longer would have to reference orange $ notation as you probably have done in your plots. You just simply just use, if you attach orange, then you can just call out the individual fields within orange. So the next thing they do is they do a quick plot. This plot is just basically showing you age to circumference, and they put a title on it here, main age to tree age to circumference. So again, they're going to look at the scatter plot, and here over in the scatter plot, then they give me in comments, again, fantastic, please, please, please do this. They showed in the comments, they say, well, I see here that there's a linear relationship, although it looks like there's some outliers. Notice the cone shape as it gets larger, and that's visually what we're seeing on this scatter plot right here. Good to call that out. The next thing they do is they do the correlation. So we did that as part of the assignment too as well. But age and circumference, and they're going to use Pearson's correlation here. So the default is Pearson's, but they're specifically calling it out. And in this case here, when they run the correlation down here in the output, 0.91. So that matches back to the output that we saw over on the heat map. If I go back to the heat map, 0.91. It's a strong correlation between these two variables. That is good. The next thing that they do is they do their linear regression. So here's your simple linear regression right here. They're predicting the y variable of circumference. That's the dependent variable. Using age, which is the explanatory variable. They run the linear regression here. They turn around, they add in the line to go with it. Nice little touch. They changed the color of the line to red, and they also changed the thickness of the line to 4. So by doing this, you can visually see it. It's easy to see it on my screen here. You can kind of see the line which we've got. Next thing they do is they run a summary. Now down here is the summary which comes out of it right here. But then what they do is they go through and they explain what you're seeing inside of the summary. Now there's been several students that have done this with the summary. So again, great to those who have done that. This is really great practice. It's really easy to just kind of understand, do you have a good model? Do you have a poor model? Where's the strengths or the weaknesses with it? So in this particular case right here, they look first at the residuals. So the residuals are right here. The residuals have 4 readings right here. The min, the max, the quartiles splits on first quartile, which is 25% is less than this. 3Q, which is 25% is greater than this. And the median. So median is close to 0, so the model is not skewed. That's good. The next thing is the min-max and the quartiles for 1 and 3. They're both close to each other. So if you look here, and you can see the min and the max, they're within 1 of each other, so that's good. The quartile 1 and the quartile 3, you can see that's just within a couple of each other's. So those are good too as well. So everything so far we're seeing here in the residuals, it's looking good. Now the residuals measure that difference between observed and predicted. So they've, again, kind of spelled out every piece of this. Coefficients come next. So the increase in age as a result of the increased circumference is around 1,1. So that's where we see here this 0.106. We can see that they round up to 0.11. That's where they're coming up with that. Standard error, which is the averaged amount of the estimate from the varies from the actual. And in this case here, it's 0.008. Standard error is right here, 0.008. So that's good. The t-value, that's the division of the estimate to the standard error. A higher level of magnitude is good. So in this case, it's almost 13. That's statistically significant, or that's an indicator that's saying it's statistically significant. But then the big closer here is the p-value. If you look at the p-value, it's an extremely small number. So And if it has a significance over 0.05, it's significant. And in this case here, it's even smaller than that. So then you've also got the stars where you can see more stars is better. And in this case here, we have 3 stars. Here's your little code right down, your key down here. So with 3 stars, you know that it's got a high degree of confidence. It's good. Continuing down through this, residual standard error right here. The standard error of 23.74 on 33 degrees. That's the y hat of how much the observed is to the predicted. And so again, that's looking pretty good, but it's also indicating 23 cases here. So it's a fairly small data set is really what that's indicating. And they call that out. If you look at the multiple R squared, you've got 83%. Okay, right here, multiple R squared. And the adjusted R squared can help also look and see about if you're having a question about overfitting. So the residual here, which we're seeing, the multiple R squared, 83.4% of the circumference can be explained by the regression. So that's good. And if I look at the R squared and the adjusted R squared, I can see that they're fairly close to each other. So again, that's kind of telling me that it's not overfit, although you are dealing with a small number of observations in this particular case. And then we've got the f-stat and the p-value. That's looking at the overall test of significance. And overall, especially if you look at this p-value, you can see that that's a very, very small number. So overall, this model is significant as a whole. They did run the confidence level here, the confidence interval. And if we see the confidence interval right here, we can see at 97.5% confidence, we can see that that's looking good as well. So then one additional piece that they added was they go into validation of the model. And so you can do that by simply plotting out the individual linear model that you produced. And that's this plot that you see here. And they've also added this parameter in here. Adding the parameter is basically going to give you a 4x4 or 2x2 grid. So it'll put 4 plots on one. If you do not use this parameter, then it will just basically throw the plots and you have to hit return to get to the next plot. So if we go to the next plot that produced, and let me blow this up for you. Here you go. So again, what we're looking for here is we're looking for this line to be as flat as possible. The line is relatively flat across all of this, although there is a little bit of a dip, which I'm seeing here, as well as some variance on the high end. So again, remember we talked about that cone on the scatter plot. We're seeing a little bit of that happening here. The QQ plot, you want it to try to be as close to possible sitting on that line, and you can kind of see there's a little bit of a dip right here in the middle. So the QQ plot is still good, although there may be some outliers, there may be some additional information to explain there. I would agree with what the student had said and saying that it's probably due to the number of observations. With more observations, this may actually just level out a little bit more. And these are, again, a couple of other predictors down here, a couple other visualizations showing that. Now, if you saw something more of like a parabola going on here, then you know that it's probably not a good model. It has issues with the model. But again, everything that we're seeing here kind of matches back to the statistics which we saw earlier. So this is looking good. And then the outcome right here, just as a kind of a final summary, is the model is significant. It's predicting circumference based on age. The relatively small amount of data is probably causing some overfitting issues, resulting in such good numbers. I would agree generally with that, but I don't think maybe what we're seeing out of the p-value up here may not say that. I'm sorry, the adjusted R squared. So what I'm seeing out of that, maybe it's not overfit, but obviously the number of observations will affect the outcome of this, and it's finely tuned at this point. So I wanted to share this back with you, and again, I think that this was an excellent response to that specific question. So if you have any additional questions on this, please let me know. Otherwise, feel free to keep this inside of your toolbox that you can use as well. Now, we're still troubleshooting the problem with some people not being able to share files. And in fact, most of the R class seems to have this problem. I have posted a zip file out to the help desk, so you can get the zip file, the compressed file out there, or you can download it from, excuse me, the GitHub. I've put a copy of all of this back up in GitHub too as well. So there's another place where you can get it. Any other questions, just please hit me up on the forums or send me an email. And again, thank you.